Welcome to the ORIC Pharmaceuticals Rinzimetostat dose optimization data update call. Earlier today, we issued a press release highlighting new clinical data and details for our first phase 3 trial. We have pre-recorded our prepared remarks, after which we will host a live Q&A session. A replay of the webcast, along with the accompanying slides, will be available on the Investor Relations section of our website for 90 days. Before we begin, during this call, we will be making forward-looking statements, including forward-looking statements based on our current expectations and projections about future events. Our actual results may differ materially from those indicated by such forward-looking statements. For a description of risk factors, please refer to our recent filings with the SEC. ORIC specifically disclaims any obligation to update any forward-looking statements. Now turning to slide 3. During today's call, we'll discuss rinzimetostat's preclinical differentiation, clinical data supporting selection of the recommended phase 3 dose, design of rinzimetostat's first phase 3 trial, and an overview of its commercial potential, followed by Q&A. Joining me on the call today, we have Jacob Chacko, CEO, Lori Friedman, CSO, Pratik Multani, CMO, Matt Panuot, CBO, and Keith Louie, Senior Vice President, Commercial and Medical Affairs. Now let me turn the call over to Jacob.
Turning to slide 5. At ORIC Pharmaceuticals, our late-stage pipeline is centered on 2 potentially best-in-class programs, each targeting large commercial opportunities. The first is rinzimetostat, a PRC2 inhibitor being developed for prostate cancer in collaboration with our partners at Bayer and Johnson & Johnson. The second is enozertinib, a brain-penetrant EGFR inhibitor being developed for non-small cell lung cancer, also in collaboration with Johnson & Johnson. Today's presentation will be focused on rinzimetostat and specifically the dose optimization data that supports our selection of a phase 3 dose and the path forward into our first phase 3 registrational trial, Himalayas-1. Turning to slide 6. Let me take a moment to frame the key takeaways from today's data update before we walk through the details. First, PRC2 inhibitors have demonstrated significant clinical benefit in metastatic CRPC with far longer radiographic progression-free survival than approved and emerging therapies in this setting. Second, rinzimetostat is a next-generation PRC2 inhibitor that was rationally designed to have best-in-class drug properties, including superior potency and a 20-hour clinical half-life that provides strong target coverage, and pharmacokinetics that successfully minimize Cmax-related toxicity. Third, we have selected rinzimetostat 400 milligrams once daily in combination with darolutamide as our recommended phase 3 dose, or RP3D, for this first phase 3 trial. This dose demonstrated a highly competitive emerging efficacy profile as measured by early landmark radiographic PFS, PSA response, and ctDNA reduction, while also demonstrating a highly differentiated safety profile with significantly lower frequency and severity of adverse events compared to competitor regimens. Finally, we expect to imminently initiate our first phase 3 trial, which will be called Himalayas-1, in post-abiraterone metastatic CRPC, a population that is a $3.5 billion total addressable market annually in the U.S. and has a lack of oral, well-tolerated therapies. We are simultaneously evaluating multiple additional potential registrational trials with the intent of starting our second phase 3 trial in 2027. Now turning to slide 7. To appreciate the opportunity ahead for rinzimetostat, it's helpful to first understand the competitive landscape in post-ARPI metastatic CRPC. Currently available therapies in this setting, including enzalutamide, docetaxel, cabazitaxel, and Pluvicto, have demonstrated median rPFS ranging from roughly 6 to 9 months, and often come with meaningful associated toxicity and administration challenges. By contrast, mevrometostat, Pfizer's PRC2 inhibitor in combination with an AR inhibitor, has demonstrated impressive median rPFS in the range of approximately 12 to 14 months, which is far longer than these other therapies. Given the alternatives, even a double-digit rPFS would be a game changer for patients in this setting, especially considering that the PRC2 regimen is an all-oral therapy. However, the mevrometostat regimen carries with it meaningful toxicity challenges. As we will discuss shortly in the slides ahead, our early data for rinzimetostat in combination with darolutamide is tracking quite favorably relative to the mevro PFS benchmarks, while also offering a substantially cleaner safety profile. Turning to slide 8. This slide provides a snapshot of the key efficacy and safety data for rinzimetostat at 400 milligrams once daily in combination with darolutamide in the far right column, and places it side by side with two key comparators, enzalutamide monotherapy in the far left column, and the combination of mevro with enzalutamide in the middle column. Starting with efficacy, the early rPFS landmark data for Rinzi plus darolutamide is highly competitive. At 3, 4, and 5 months, our combination achieved landmark rPFS percentages that are essentially identical to the mevro combination and far higher than those of AR inhibitor monotherapy. For that matter, the rinzimetostat landmark rPFS percentages outperform those of the various alternative therapies listed on the prior page, like Pluvicto and chemotherapy as well. What is even more remarkable, though, is that Rinzi's strong efficacy is accompanied by an exquisitely clean safety profile. The safety profile for our 400 milligram dose in combination with darolutamide is markedly cleaner than what has been reported in the mevro regimen, with Pluvicto or with chemotherapy. The most common treatment-related adverse events for the Rinzi-Daro combination are fatigue, diarrhea, and nausea, all of which occur at relatively low rates, and critically, all are grade 1 or 2. Treatment modifications of any kind were exceedingly rare. The contrast versus our competitor safety profile and versus other alternatives in this space is stark. Finally, turning to slide 9, I want to briefly review the magnitude of the opportunity that lies before us. In prostate cancer alone, we estimate that rinzimetostat has the potential to reach approximately 70,000 patients in the U.S. annually across 3 distinct indications. The initial target population, post-abiraterone metastatic CRPC, is today roughly a $3.5 billion annual total addressable market in the U.S. alone. With additional prostate populations, like post-AR inhibitor metastatic CRPC and metastatic castration-sensitive prostate cancer, the opportunity grows substantially, with the metastatic CSPC setting alone being a potential market of greater than $10 billion annually in the U.S. Beyond prostate cancer, we also see meaningful future development opportunities for Rinzi in other settings, including non-small cell lung cancer, colorectal cancer, and breast cancer, where the biology of PRC2 inhibition may similarly enable combination strategies with various approved and investigational therapies. With that, let me hand the call over to Lori to walk through the preclinical rationale for Rinzi before Pratik walks us through the clinical data. Lori?
Thanks, Jacob. It's my pleasure to talk about PRC2 and our excitement for developing rinzimetostat in prostate cancer. Turning to slide 11, PRC2 has been a target of interest for many years. However, the first-generation inhibitors such as CPI-1205 and tazemetostat had multiple shortcomings, as shown in the left side of the table. Mevrometostat, a second-generation inhibitor, addressed some of these issues, including cell potency and CYP autoinduction, yet falls short in other drug properties such as solubility and half-life. Rinzimetostat shows improvement in all categories, including drug properties that result in a 20-hour half-life in the clinic. Thus, Rinzi has potential as a best-in-class PRC2 inhibitor that addresses all the limitations of earlier generation inhibitors. On slide 12 are 2 examples of preclinical in vitro data demonstrating the superior potency of rinzimetostat to first-generation PRC2 inhibitors. In these dose-ranging studies, AR-positive prostate cancer cell lines were treated head-to-head with 4 different drugs and assayed for effects on cell growth and viability. The cell potency for first-generation inhibitors, shown in black and dark blue curves, are right-shifted due to their weaker potencies. Rinzimetostat demonstrates comparable potency to mevrometostat in prostate cancer cell lines and superiority to the first-generation PRC2 inhibitors. The graphic on slide 13 summarizes how therapeutically targeting PRC2 reverses the evolution of prostate cancer. As prostate cancers are treated with hormone blockade or with AR-targeted agents, they evolve to evade these therapies. Going from left to right, the illustration shows prostate tumors progressing from castration-sensitive to insensitive, and from AR-dependent to AR-independent. Epigenetic reprogramming is the mechanism by which prostate cancer cells transition to change their cell state to escape therapeutic pressure. PRC2 inhibition can reverse this process and even prevent the transition, so that prostate cancer cells regain and maintain their luminal cell state and their dependency on AR. This mechanistic rationale supports the combination of PRC2 inhibitors with AR inhibitors and suggests that the therapeutic potential of rinzimetostat in prostate cancer will be maximized in combination with AR inhibitors. On slide 14 is an example of preclinical data supporting the mechanistic rationale, where PRC2 inhibition with rinzimetostat sensitizes prostate cancers to AR inhibition through epigenetic reprogramming. In the two experiments shown here, with a CRPC model on the left and a CSPC model on the right, prostate cancers were treated with either rinzimetostat or the vehicle control, and tumors were then assessed for transcriptional changes using RNA sequencing. Two consistent changes were observed: a significant increase in AR signaling and a significant increase in luminal cell state markers. These transcriptional shifts result in the prostate tumors having an increased dependency on the androgen receptor. Slide 15 shows how rinzimetostat further controls epigenetic reprogramming at the level of chromatin modification in experiments using ATAC sequencing. These volcano plots depict transcription factor sites on chromatin that are either significantly opened, shown in orange, or significantly closed, shown in blue. On the prior slide, I showed how luminal and AR transcriptional signatures were increased following rinzi treatment. In these experiments, we also see that important transcription factor sites are closed, and notably, these closed sites are known to drive lineage escape in prostate cancer, such as 1CUT2 and FOXA1-AR half sites. This ability of rinzimetostat to reduce accessibility to lineage escape factors means that rinzi has the potential to prevent resistance from arising. And again, like the prior slide, we see the same mechanism in both CRPC and CSPC models. Moving forward to in vivo efficacy on slide 16, on the left is an example of a study where castration-resistant prostate cancer xenografts were treated with darolutamide with and without PRC2 inhibitors. The combination of rinzimetostat with darolutamide impressively improved progression-free survival in this castration-resistant setting. On the right is a similar study, only this time the combination was assessed in castration-sensitive prostate cancer xenografts. Once again, adding rinzimetostat to darolutamide increased the progression-free survival. Thus, rinzimetostat has been shown to combine with AR inhibition in prostate cancer xenografts to improve survival in both CRPC and CSPC settings. And importantly, with rinzimetostat's improved drug properties, it stands out as a potential best-in-class PRC2 inhibitor. We're excited to see Rinzi's progress in the clinic, as Pratik will tell you about.
Thank you, Lori. Turning to slide 18, it's my pleasure to provide an update of the dose optimization data from our phase 1b trial of rinzimetostat and the extensive work we've done to select the recommended phase 3 dose to take into our first registrational trial. This trial is a multi-center study being conducted in 4 countries in patients with metastatic prostate cancer. Initially, we explored rinzimetostat as a single agent at doses ranging from 100 milligrams to 900 milligrams once daily. These data established Rinzi's strong pharmaceutical properties, including dose proportional exposure, no evidence of CYP autoinduction, and a 20-hour clinical half-life allowing once daily dosing. We also demonstrated robust target engagement at doses as low as 200 milligrams and a well-tolerated safety profile, with a single-agent maximal tolerated dose of 800 milligrams, giving us a wide therapeutic window and making Rinzi highly suitable for drug combination. Collectively, these properties differentiated rinzimetostat from other PRC2 inhibitors and positioned it as a potential best-in-class molecule. We then proceeded to combination dose finding, conducted in parallel with both darolutamide and apalutamide, and have previously presented data from this experience last year. After determining the candidate RP3Ds for each AR inhibitor combination, we then embarked upon comprehensive dose optimization, randomizing patients to receive one of the 2 RP3Ds selected for each AR inhibitor, respectively. This dose optimization was conducted in 2 separate patient populations with metastatic prostate cancer, one in patients who had previously received abiraterone, and the other in patients who had previously received a second-generation androgen receptor inhibitor, namely apalutamide, enzalutamide, or darolutamide. Today's update will focus on our dose optimization work with rinzimetostat in combination with darolutamide in the post-abiraterone patient population. Before I get into the new dose optimization clinical data, turning to slide 19, I wanted to spend a minute talking about the pharmacokinetic and pharmacodynamic results that underpin our decision-making around optimal dose and RP3D selection. On the left of this slide is a PK plot of rinzimetostat over 24 hours for the two doses selected for dose optimization with darolutamide, 400 milligrams and 600 milligrams once daily. You can see that both blue curves peak at 4 hours with a gradual decay over 24 hours, demonstrating Rinzi's 20-hour half-life and well-behaved pharmacokinetics. Superimposed on these two curves in shades of gray are the single-agent PK curves for the same doses of rinzimetostat, highlighting the lack of drug-drug interaction between Rinzi and Daro. The two dotted red lines superimposed on this PK plot represent target minimum concentrations from our preclinical work. The key point here is that both doses cover the target exposure for the full 24 hours. On the right, we have pharmacodynamic data, looking at the level of H3K27 trimethylation levels in PBMCs. Both as a single agent or in combination with darolutamide, we maximize the PD signal in this readout at both 400 and 600 milligrams. And from our single agent work, you can see that we even cover the target at 200 milligrams. So these data collectively support our choice to take two dose levels into dose optimization that were both predicted to be efficacious. Turning to slide 20 and our clinical data, you can see the demographics and baseline characteristics of the patients treated with rinzimetostat at 400 and 600 in combination with darolutamide in patients with mCRPC post-abiraterone. Overall, these patients were more heavily pretreated than those from recent competitor data sets. The median baseline PSA was 26 for the 400 milligram dose and 12 for the 600 milligram dose. While the median baseline PSA of 12 is comparable to what's been seen in other mCRPC data sets, the median of 26 in the 400 milligram group is considerably higher. In terms of treatment history, patients at both doses had a median of 2 prior therapies, not counting ADT. They all had received prior abiraterone, with many receiving prior docetaxel, as well as additional therapies, such as immune therapy, radium-223, or PARP inhibitors. This prior treatment history makes our population more heavily pretreated than the disclosed mevrometostat experience, which only allowed prior abiraterone and up to 1 prior chemotherapy and no other therapies. Finally, tables like these conventionally show median age in the first row with little comment, but I think it's important to point out that the median age here, as in most studies in metastatic prostate cancer, was 70 years overall, meaning that this is a more fragile elderly population with less tolerance for drug-related toxicity. Slide 21 shows the safety profile of rinzimetostat at 400 and 600 milligrams in combination with darolutamide. You can clearly see that almost all adverse events are either grade 1 or 2. In fact, across all 33 patients at both dose levels, there was only 1 grade 3 event. There were also no grade 4 or 5 treatment-related adverse events at either dose. The most frequent adverse events include fatigue, which can be attributed not only to rinzimetostat, but also the AR inhibitor darolutamide and to the patient's cancer itself. Next on the list are GI-related toxicities, diarrhea, and nausea. These side effects can be particularly troublesome if they are chronic, even at grade 2 in severity, because they can significantly impact a patient's quality of life. You'll note that at the 400 milligram dose, most of these events were grade 1, whereas at 600 milligrams, there was a generally higher rate of grade 2 events. This safety trend can be seen more clearly on slide 22, where we pull back and include 39 additional patients from the post-AR inhibitor dose optimization cohorts. The overall safety experience here is larger, with 37 patients at the 400 milligram dose level and 35 patients at the 600 milligram dose level. Again, there are few grade 3 events overall, but there remains a trend towards fewer grade 2 versus grade 1 adverse events at the 400 milligram dose level versus 600, especially with the important potential quality of life toxicities of diarrhea and nausea. In keeping with this observation, the rate of diarrhea at 400 is also just about half the rate at 600, 19% versus 37% respectively. Nausea is also lower at 400 milligrams and entirely grade 1 compared with 600 milligrams. From a safety perspective, both dose levels appear to be well tolerated. However, for a drug where long-term dosing is expected for months and even years, minimizing the incidence of even grade 2 events can be critical to patient adherence. For the treatment to work, patients need to stay on therapy and they need to maintain that therapy without frequent interruptions for toxicity, since interruptions can lead to loss of target coverage and compromise efficacy. Furthermore, these factors become even more critical if you intend to move the drug earlier in the course of disease, for example, into the CSPC setting where we are planning future potential phase 3 trials. Turning to slide 23, we have additional safety data, specifically various types of treatment modification events, rates of dose interruptions, dose reductions, and treatment discontinuations presented for both the post-abiraterone population and the broader post-ARPI population. The general trends that we just saw with the adverse event tables are also evident here. Both the 400 and 600 milligram dose groups have event rates that are lower than competitor regimens, but the 400 milligram remains more favorable than the 600 milligrams, with lower rates of treatment modifications across the board. With that in mind, let's turn to slide 24, which outlines the work we did to satisfy the requirements of FDA's Project Optimus and formally select the rinzimetostat recommended phase 3 dose in combination with darolutamide. To do this, we performed an extensive set of exposure-response analyses that looked for correlations between drug exposure and a range of measures of both safety and efficacy. Drug exposure was quantified multiple ways. We looked at Cmin, the lowest concentration over 24 hours. We looked at Cmax, which is the highest concentration, and we looked at AUC, a measure of overall exposure, including accounting for individual patient dose modifications. Safety measures we examined included the rate of grade 2 or higher adverse events, grade 3 or higher events, or serious adverse events. We also looked for correlations between exposure and specific subsets of adverse events of interest, such as gastrointestinal or hematologic toxicities. And finally, we looked at the relationship between exposure and rates of treatment modifications. On the efficacy side, we looked at correlations with radiographic progression-free survival, with PSA reduction, both categorically as a response rate and as a continuous variable. We also looked at reduction in ctDNA and at pharmacodynamic readouts such as changes in H3K27 trimethylation. Overall, this in-depth analysis showed that both 400 and 600 milligrams provided comparable efficacy. There was substantial overlap in exposure distributions between responders and non-responders on any measure of efficacy, including progression-free survival, without statistical significance. Thus, the 600 milligram dose was statistically comparable to and not superior to the 400 milligram dose. In terms of safety, however, the ER analysis showed statistically significant relationships between exposure and clinically meaningful toxicities, as well as statistically significant correlations between higher exposures and higher rates of treatment modifications. Thus, on the basis of safety, the 400 milligram dose was clearly favored over the 600 milligram dose. Overall, the conclusions from this ER analysis were unambiguous, with no advantage in efficacy at the higher dose, but a clear statistically significant advantage in safety at 400 milligrams. Therefore, the definitive conclusion from this work is that 400 milligrams is the preferred RP3D for rinzimetostat in combination with darolutamide. With 400 milligrams selected as our recommended phase 3 dose of rinzimetostat in combination with darolutamide, let's now take a look at its efficacy profile over the next few slides, beginning on slide 26. We would hope to replicate this efficacy profile in the upcoming phase 3 trial, which, if we do, would yield a therapy that is more effective and yet safer than options currently available to these patients today. In fact, we may even be able to improve upon this profile given the more heavily pretreated nature of the patients we treated in dose optimization versus those we would be enrolling in our upcoming phase 3 trial. On this slide, we have a PSA waterfall plot of the best percentage change in PSA from baseline for the 15 patients with mCRPC post-abiraterone who had a PSA measurement by the data cutoff. You can see strong clinical activity with a 47% unconfirmed and 33% confirmed PSA 50 response rate. Multiple of these patients remain on treatment, offering the potential for further deepening of responses. Slide 27 depicts a waterfall of the best percentage change in circulating tumor DNA fraction and shows a similar impressive molecular response. 71% of patients had a 50% ctDNA reduction and 29% had a 90% reduction. To put this into context, this 71% rate of reductions is meaningfully higher than what was seen with enzalutamide in the Ambassador 250 study, for example. Of note, these rinzimetostat ctDNA responses were seen across a variety of AR alterations, including point mutations, AR amplifications, as well as the wild-type setting. These impressive data are important, especially given the established strong correlation between ctDNA reduction and long-term durability. Finally, slide 28 depicts the time on treatment swimmer plot for the 18 patients in dose optimization at the 400 milligram dose. The plot depicts which patients have had radiographic progression events and their timing, as well as which patients remain on study. On the left, along the y-axis, we have listed the prior treatment history outside of ADT for each of the patients as well. Follow-up is still early, but with a median follow-up of 4.9 months, you can see in the embedded table on the right the landmark radiographic progression-free survival at 3 time points where we have reliable data, 3, 4, and 5 months. At 3 months, an impressive 93% of patients remain progression-free, which is then 84% at the 4 and 5 month landmarks, meaningfully higher than what you would expect from an ARPI switch alone. With further follow-up, we will be able to extend our estimate of long-term durability. But at this early stage, we are excited by the durability that we're seeing. Now, to put all these data that I presented into context, slide 29 compares the safety profile that we have developed for rinzimetostat 400 milligrams in combination with darolutamide versus the disclosed safety profile for mevrometostat, both at 1250 milligrams BID fasted and their more recent data at 875 milligrams BID fed. We can't do a complete comparison because for mevrometostat, we only know the adverse events that occurred with a 20% or higher incidence. You can see that the adverse event profile of rinzimetostat stacks up very well against the mevrometostat results, regardless of whether you're looking at the fasted or fed mevro regimen. Specifically, for all the adverse events disclosed for mevrometostat, the incidence with rinzimetostat is lower in each case, with the one exception of a slightly higher overall rate of fatigue versus the Mevro 875 fed regimen. But even here, there are no grade 3 events with Rinzi, while there are with Mevro. In addition, there are a number of adverse events reported with Mevro that we don't see to any appreciable degree with Rinzi, such as alopecia, neutropenia, thrombocytopenia, or vomiting. Slide 30 extends these safety observations, summarizing the rate of grade 3 adverse events, serious related adverse events, dose reductions, and treatment discontinuations for Rinzi with darolutamide versus Mevro with enzalutamide. You can see that across all of these tolerability metrics, the 400 milligram rinzimetostat dose in combination with darolutamide demonstrated a clearly differentiated safety profile from both mevrometostat plus enzalutamide dosing regimens, with a lower rate of grade 3 adverse events, no serious related adverse events, no dose reductions, and few discontinuations. This differentiated profile, we feel, is highly compatible with long-term dosing and sustained patient adherence. Slide 31 summarizes the important elements of safety and efficacy from the rinzimetostat data, with a benchmark comparison to the same results for the mevrometostat combination, both with their fasted and fed regimens, as well as enzalutamide single agent. But before I walk through this, I wanted to again point out that our study was conducted in patients who were more heavily pretreated than in the mevro studies, and they had a higher baseline PSA, 26 for the Rinzi patient population, compared with 15.5 and 16.7 for the two mevro groups. Now, in terms of radiographic progression-free survival, we have less follow-up than the mevrometostat patients, approximately 5 months median follow-up compared with 9 to 11 plus months for mevro. But for the rPFS landmarks that are available for comparison at 3, 4, and 5 months, the rinzimetostat data are nearly identical to the mevro data and superior to the enzalutamide single-agent data. In terms of safety, on the other hand, any way you look at it, by the rate of grade 3 adverse events or the rate of dose reductions or discontinuations, rinzimetostat appears to be markedly safer than the competitor benchmark. Overall, we feel very good about the safety and efficacy profile we have developed for rinzimetostat at the 400 milligram dose in combination with darolutamide, a profile that positions it well for success as we now move to phase 3 development. Turning to slide 33, with this strong rinzimetostat profile in hand, and having selected the RP3D of 400 milligrams in combination with darolutamide, I'm excited to unveil our first phase 3 trial, which we are calling Himalayas-1. You can see the design of Himalayas-1 here. This study will be conducted in patients with metastatic castration-resistant prostate cancer who have previously been treated with abiraterone and have had up to 1 prior chemotherapy in the CSPC setting. Patients will be randomized 1-to-1 between a combination of rinzimetostat and darolutamide versus physician's choice of an AR inhibitor or chemotherapy. The primary endpoint of the study will be radiographic progression-free survival, with overall survival as a key secondary endpoint. We are far along in study startup activities, having selected over 250 sites in over 20 countries in North America, South America, Europe, and across Asia Pacific. And to help us in the conduct of this study, turning to slide 34, we have engaged many of the world's leading experts in the treatment of prostate cancer as members of the Himalayas-1 steering committee. The committee chair is Matthew Smith of Massachusetts General Hospital, and the vice chair is Karim Pizazi of Gustave Roussy. Additional members include Johan de Bono of the Royal Marsden, Arun Azad of Peter Mac, Elizabeth Heath of the Mayo Clinic, Joaquin Mateo of Vall d'Hebron, Rahul Agarwal of UCSF, and Wasim Abida of Memorial Sloan Kettering, basically a who's who of international thought leaders in the field of new therapies for prostate cancer. With the expertise of our steering committee and the partnership with many GU oncologists and urologists around the world who have agreed to participate in our trial, we have strong momentum to initiate Himalayas-1 in the first half of this year. Now turning to slide 35. As a final step to our regimen selection, one that is required by FDA, we are conducting a food effect study. We did look at food effect of rinzimetostat as a single agent and didn't see a significant impact of dosing with food on Rinzi exposure. We're now repeating this with the Rinzi-Daro combination, and so far we are not seeing a significant food effect here either. Of note, the early data in this food effect cohort continues to look good on efficacy and safety. In the first 5 patients in this cohort who are evaluable for PSA response, we have observed a confirmed PSA 90 as well as 2 confirmed PSA 50s. And all safety events noted thus far are grade 1 with 1 grade 2 related event. This obviously gives us further confidence in our choice of the 400 milligram dose for phase 3 development. Finally, on slide 36, while we are hyper-focused on near-term initiation and execution of our Himalayas-1 phase 3 trial, we are simultaneously exploring additional indications in which we may conduct future phase 3 studies. Earlier in the presentation, Lori presented compelling preclinical data suggesting that the therapeutic benefit of a PRC2 inhibitor may translate to the CSPC setting. In addition, as I stated earlier, with our ongoing phase 1b trial, we are currently generating clinical data looking at rinzimetostat with darolutamide in the post-AR inhibitor mCRPC patient population. Here on this slide, we have a preliminary look at the time on treatment swimmer plot in these post-AR inhibitor patients at the 400 milligram RP3D dose. Follow-up is still early with a median of 4.8 months, but the 3, 4, and 5-month landmarks are very encouraging, with 93% progression-free at 3 months, going to 85% at 4 and 5 months, and 8 of these 19 patients are still on treatment. This performance is particularly striking given that an AR inhibitor alone after a prior AR inhibitor would be expected to give a PFS of 2 to 3 months at best. These data leave little doubt in our minds as to the potential of rinzimetostat more broadly in patients with prostate cancer. Now let me hand it over to Keith, who will outline Rinzi's commercial potential. Keith?
Thanks, Pratik. Turning to slide 38, as Pratik highlighted earlier, based on the highly differentiated rinzimetostat RP3D efficacy and safety profile, we are excited about the upcoming initiation of Himalayas-1 in post-abiraterone mCRPC. From a commercial perspective, the next logical question is, how large is that market? And the answer to that question is driven by the widespread use of abiraterone both in the US and globally that makes it by far the world's most prescribed ARPI. As the first ARPI approved by the FDA for prostate cancer, abiraterone remains the leading ARPI, accounting for approximately half of new ARPI prescriptions annually, as evidenced by real-world, clinical trial, and prescription data. Turning to slide 39, this is how we think about the total addressable market in post-abiraterone mCRPC. In the US, we estimate that the annual incidence of mCRPC patients previously treated with abiraterone is approximately 17,000. Then, based on mevrometostat phase 2 combination data, we estimate a treatment duration of about 14 months. Finally, factoring in the current day pricing of advanced prostate cancer therapies, we arrive at an addressable market in the US of over $3.5 billion and a total global addressable market of around $7 billion for this first indication alone. As Jacob and Pratik noted earlier, PRC2 inhibitors have demonstrated significant clinical benefit in mCRPC with far longer radiographic PFS than approved and emerging therapies in this setting. Rinzimetostat, albeit early, thus far is tracking to the same long durability. But importantly, Rinzi is already well on its way to establishing a highly differentiated safety profile that would stand in a class of its own. And so, as we model out future share scenarios, we are really looking at 2 potential future cases, both of which assume that Rinzi continues to demonstrate a best-in-disease safety profile. In a minimal case, Rinzi achieves equivalent efficacy to other PRC2 inhibitors, which as stated earlier is far longer than other currently available therapeutic alternatives. And in a scenario more akin to our base case, Rinzi is able to achieve differentiated efficacy as well. Obviously, either case results in a substantial rinzimetostat share of the $7 billion post-abiraterone mCRPC market. Turning to slide 40, to pressure test the minimal case where Rinzi maintains its highly differentiated safety advantage but achieves only equivalent efficacy to other PRC2 inhibitors, we conducted independent market research with US-based academic and community urologists and oncologists. The physicians assessed blinded target product profiles of rinzimetostat, noted in the research as product Y, in combination with darolutamide, against a competitor PRC2 inhibitor noted as product Z, in combination with enzalutamide in post-abiraterone mCRPC. The TPPs reflected similar efficacy, but a more favorable safety profile for the Rinzi plus Daro combination that was similar to the 400 milligram safety profile Pratik shared earlier in his presentation. The key insight from our research was that physicians indicated they would ascribe the blinded rinzimetostat profile 80% share of the PRC2 class, reinforcing the notion that a differentiated, best-in-disease safety profile alone can drive prescribing decisions and significant market share, especially considering the demographics of this patient population. This prescribing preference is reflected in multiple quotes throughout the research, where prescribers express strong preference for product Y based on the safety benefit alone. Turning now to slide 41, I want to revisit the commercial potential that Jacob spoke to earlier in the presentation. In the U.S., our initial launch indication in post-abiraterone mCRPC represents approximately 17,000 patients per year alone, with a total addressable market of greater than $3.5 billion annually. With additional development potential in prostate populations like post-AR inhibitor mCRPC, where we showed promising early landmark PFS data, and metastatic castration-sensitive prostate cancer, where Lori showed strong preclinical data, the commercial opportunity grows significantly, with the mCSPC indication alone representing a potential market of greater than $10 billion just in the U.S. Beyond prostate cancer, we also see multiple future development opportunities for rinzimetostat in other tumor settings, where PRC2 inhibition, combined with various approved and investigational therapies, may address various unmet medical needs. I'll now hand it back over to Jacob to discuss next steps and close out our session. Jacob?
Thank you, Keith. We'll wrap up our prepared remarks on slide 43. We continue to be excited about the development prospects for both our clinical programs and their emerging best-in-class profiles. Within prostate cancer, we believe the dose optimization data presented today build a strong case that rinzimetostat, in combination with darolutamide in our upcoming Himalayas-1 registrational trial, has the potential to yield profound benefit for patients in a market that is large but woefully underserved today by oral, well-tolerated therapies. Before we begin Q&A, I'd like to thank our investigators, as well as the entire ORIC team who've worked diligently to tackle our mission on behalf of patients. And most importantly, I want to thank our patients and their families, whom we hope to help overcome resistance in cancer. With that, let's open it up for Q&A.
Thank you. As a reminder, to ask a question, please press star 11 on your telephone and wait for your name to be announced. To withdraw your question, please press star 11 again. In fairness to all, we ask that you please limit yourselves to one question and one follow-up. One moment for our first question. Our first question comes from the line of Anupam Rama with JP Morgan. Your line is open. Please go ahead.
Hi, guys. Thanks so much for the comprehensive update and congrats on the update. So based on physician feedback, we previously laid out these win scenarios, right, which what it would take to establish sort of a best-in-class profile, and it was really driven by safety differentiation alone. Today in your update, you repeatedly talked about a best-in-disease profile. What gives you confidence that rinzimetostat's profile is tracking to a best-in-disease profile that can be replicated in later stage studies? That's the first question. And the second one is, can you give us any color on any FDA feedback you got on the phase 3 study and how this impacts your start time for the phase 3? Thanks so much. Oh, I can't hear you guys.
Speakers, you need to unmute.
I can't, yeah.
Michelle, can you hear us? Can you tell me?
I can now, sir.
Yep.
Can you hear us now?
Yes, sir.
Anupam, can you hear me?
Yep, I can.
Okay. Sorry, I don't know what happened with the audio on our side. Thanks for your question, Anupam. I'll do your first question, and then I'll ask Pratik, our CMO, to cover your second question. Short answer is we're super excited about the profile that we're seeing from rinzimetostat right now, frankly, in combination with either of the AR inhibitors, but right now we're focused on the Rinzi plus Daro update. As the program's advanced and, now we're months away from initiation of the first phase 3 trial, we're seeing an emerging profile in that post-ARPI metastatic CRPC setting that is highly differentiated from not only mevrometostat, but all the other alternatives that a patient in that space could have today available to them. So the only other PRC2 inhibitor, as you know, that's currently in prostate phase 3 trials is Mevro, and they've shown RPFS from a randomized trial that's substantially better than all the available standard of care therapies for these patients. We laid that out early in the deck. With Rinzi, while we don't yet have a mature rPFS number, the landmark rPFS rates obviously are tracking nicely. They're essentially identical to those from Mevro, and that's despite, as Pratik said, our population being more heavily pretreated and with a meaningfully higher baseline PSA. So obviously, intuitively, you can draw a strong correlation between landmark rPFS and eventual mature rPFS performance. And again, slide 7 in our deck shows exactly that across a whole variety of treatments in first-line metastatic CRPC. So we believe that means that Rinzi is tracking to have the same kind of durability, if not better than Mevro. And hopefully that gets better once we get to a like-for-like population with Mevro in a phase 3 study. But on top of that, this is what's really important to note, Anupam, is Mevro's stellar rPFS comes with a tox profile that obviously leaves significant room for improvement with high rates of GI and heme tox, as well as things like dysgeusia and alopecia. So far, the safety profile of Rinzi looks markedly better than that. And for that matter, the safety profile looks better than what you'd see with Pluvicto, chemo, T-cell engagers, you name it. So if this profile continues to hold into the Himalayas-1 trial, it would set up Rinzi to have a combined efficacy and safety profile that's obviously head and shoulders above any of the mechanisms available to these patients today. So that's why we're so excited about the potential for Rinzi and its potential to become a best-in-disease therapeutic option for these patients. Now, let me have Pratik cover your second question.
Sure. So happy to do so. Your second question was about FDA feedback in the phase 3. So we've had regular communication with the FDA, as you can imagine, all along as the program has progressed. I can't get into specifics, but we are planning an end of phase 1 meeting in Q2 to get their final sign-off on the RP3D selection, the 400 milligrams that we presented today, as well as the final design of the Himalayas-1 protocol. There's also some other topics in terms of clinical pharmacology studies, et cetera, but we feel really good going into that end-of-phase meeting. And that should put us on the timeline, as Jacob outlined, to start still in the second quarter this year.
Thanks so much for taking our questions.
Thanks, Anupam.
Thank you. And one moment for our next question. Our next question comes from the line of Prakhar Agrawal with Cantor. Your line is open. Please go ahead.
Hi, thanks for taking my questions. I had a couple. So maybe just if you can expand on the baselines of the patient population in this readout compared to the Mevro population. I think you hinted at that during the prepared remarks, and specifically as it relates to the implications on efficacy on PSA as well as PFS. And secondly, ctDNA reductions that you have observed, could you contextualize that as well? The 71% ctDNA molecular response, how does that compare to some of the other prostate drugs? Thank you.
Yeah, thanks, Prakhar. We'll have Pratik take your first question, and then Lori, our CSO, will take your second question.
Sure, thanks. So as Jacob already sort of hinted at, as a headline, I'd say that our patient population is more advanced, has a higher baseline PSA and on median, and then more prior therapies. So our post-abiraterone 400 milligram dose group, the median baseline PSA was 26. This is meaningfully higher than the baseline for either of the mevrometostat data sets. As you'll recall from the randomized experience with the 1250 BID fasted regimen, they had 41 patients post-ABI, and the median baseline PSA was 15.5. And then their more recent update at ASCO GU last month with the 875 BID fed regimen, the regimen they're taking into all of their phase 3s. There, in 14 patients post-ABI, the median baseline PSA was 16.7. So ours is meaningfully higher at 26 than theirs in the mid-teens. In terms of prior therapy, our data set includes patients who have had additional prior therapies beyond ABI and possibly docetaxel. So the Mevro data set, on the other hand, was restricted to just prior ABI and possibly docetaxel alone. One other thing I would just point out is that in our study, we enrolled far more African American patients. 30% of our patients in dose optimization were Black or African American. And as you probably know, prostate cancer is overrepresented in this population. And so I would say we did a good job of reflecting the real-world demographics of prostate cancer. Mevro just had 5% in their randomized data set, none in their more recent update. So as I said, our patient population is more advanced. It has a higher baseline PSA and more prior therapies.
Okay, for the second question, just doing a sound check. All right, so this question, Prakar, you asked about ctDNA reductions and how to contextualize those. So
Yes.
given that we know rinzimetostat mechanism of action is to enhance the luminal cell state and increase AR signaling, ctDNA reduction is even a better read-through of treatment effect on tumor burden than PSA. While we do see strong PSA responses, we're even more excited to evaluate the ctDNA reduction and clearance, which have been shown to associate with long-term PFS and overall survival, even more strongly than PSA. In this dose optimization cohort of 400 mg of Rinzi plus darolutamide, the molecular response rate is an impressive 71%. We have no way to compare this ctDNA response to Pfizer's mevrometostat. They've measured ctDNA reductions, but they haven't publicly released it. So to give context to Rinzi's 71% molecular response, this result is superior to other active therapies in similar patient populations. For example, in the Ambassador 250 and Comrade studies assessing AR inhibition and radium-223, the molecular response rates were at 28% and 44%. In treatment-naive metastatic CRPC populations that receive standard of care, the reported rates of molecular response range from 65 to 78%, making our ctDNA response of 71% in the pre-treated population that much more notable. So I'm very pleased with this.
Thank you. And one moment for our next question. Our next question will come from the line of Brad Canino with Guggenheim. Your line is open. Please go ahead.
Afternoon. Thanks for the questions. It was good to hear the key factors that led to the selection of darolutamide instead of apalutamide. And then you've shown some strong early durability with the landmark rPFS that you put in the slides. But can you also provide some additional color on what you saw on stuff like PSA kinetics or resist responses that help support that rPFS as well? Thank you.
Thanks, Brad. I'll take your first question on the choice of AR combo partner, and then Pratik will cover your second one. So obviously, we've generated a lot of data over the last several years with both Daro and APA as combination regimens for Rinzi. Both Daro and APA are great drugs and great combo partners for Rinzi, so can't say enough good high compliments about both of those programs. You know, as we've commented many times in the past, we see similar efficacy and similar safety with both combo agents. You know, obviously one big difference that's not a surprise for folks is that apalutamide, and for that matter, enzalutamide, has the same factor going for it, which is they're well characterized as CYP inducers. And so they will push down the exposure of other drugs, most other drugs that are co-administered with them, just given how many drugs are metabolized by the CYP enzymes. So mevrometostat is clearly going to experience that same DDI when they're dosed with enzalutamide. And while that type of DDI can be overcome through higher dosing, you know, and obviously we're taking higher doses into our dose optimization with for rinzimetostat with apalutamide than we are with darolutamide, we chose for this first phase 3 study to just go with the simpler path of no DDI. And so that's to combine it with darolutamide. And, you know, I should say, obviously, choosing darolutamide for this first phase 3 study, we're quite excited about that, but it obviously doesn't preclude us from using apalutamide in subsequent phase 3 studies. And let me ask Pratik to take your second question.
Sure. So, as we progress the Rinzi program to later stage and as the data mature and more follow-up, the most important endpoint clearly is radiographic progression-free survival. It's the main regulatory endpoint for this patient population, and it's going to be, as I said, the sole primary endpoint of Himalayas-1. Overall survival is an important secondary. So we focused today's presentation on the landmark rPFS through our median follow-up of 5 months, since we don't yet fully have a mature PFS for the later time points. And, you know, as just to reprise some of what I presented, looking at the 5-month landmark in the post-Abi population, it's 84%, which is right on top of the mevrometostat data. And if you look at the same 5-month values for other approved agents for these patients, they range from 60 to 75%, so well south of what we're seeing in our patient population. And then also, near the end of my presentation, I also gave a preview of what we're seeing in the post-AR inhibitor population with the Rinzi-Daro combination. And here, again, the 5-month landmark of RPFS is 85%, where you'd expect the median to be something like 2 to 3 months only. So, really much better than conventional therapy. So this gives us a lot of confidence, both in terms of the activity, the mechanism, and the dose that we picked to go forward into phase 3. Now, with respect to RECIST responses, we definitely looked at additional points of correlation, but most of our patients have bone-only disease. That's typical for this patient population. And so for the few patients that have soft tissue disease, of those, only a subset have lesions large enough to be RECIST measurable. So that leaves us with just a handful of patients with measurable lesions at 400 milligrams, and we have 100% disease control rate in those patients. And we have seen confirmed RECIST responses at both 400 and 600. So we do see tumor shrinkage, but the low number of patients who are RECIST evaluable makes calculating an ORR not terribly informative. In terms of PSA kinetics, PSA is actually kind of interesting with respect to the mechanism of PRC2 inhibition. If you go back when we were doing our preclinical work and the effect of PRC2 had on increasing AR signaling, one of the side effects of that is it can drive up PSA because it increases the expression of the gene for PSA. So we initially expected actually that PSA would go up, and that's basically what we saw in our single agent experience. The PSA went up in all the patients. So we wondered actually what might happen when we combined with an AR inhibitor. Would the PSA actually go down, or would it even be uninterpretable? So we were glad to see the initial Pfizer data in their combination that the PSA could go down, and as you can see, we're seeing that in our patients as well. So the net effect of the combination regimen can drive down PSA, but it does take time to develop. In our experience, many patients, the reductions can happen over the first 2 or 3 cycles, so 2 or 3 months, but we've seen further reductions out past 6 months and even 9 months. And so, really because of the limitations of looking at RECIST response, not a lot of patients, and the limitations of PSA given the PRC2 mechanism, it's why we've actually looked hard at ctDNA, which is a more direct measure of disease burden and can be evaluated for most patients. They're all evaluable for ctDNA except for a few exceptions. And so that ctDNA response has been correlated with long-term durability. And on this measure, our molecular response rates are higher than what's been reported for other active agents in this patient population.
Thank you. And one moment for our next question. Our next question will come from the line of Maury Raycroft with Jefferies. Your line is open. Please go ahead.
Hi, congrats on the update, and thanks for taking my questions. You mentioned that the 400 mg and 600 mg doses had comparable efficacy. Is there any additional color you can provide on what you observed on efficacy at 600 mg? And do you have enough data to know for sure that there's no additional benefit on RPFS with the 600 mg dose?
Yeah, Pratik can handle that, Maury. Thanks for the question.
Sure. So, the objective of the presentation today was to lay the groundwork for our first phase 3 study. So we wanted to, identify the patient population, identify the AR inhibitor that we were going to combine with, and then complete dose optimization and select the dose going forward. And so the bulk of the presentation was then focused on this RP3 dose selection and the regimen. And that selection, as you heard, is 400 milligrams once a day with darolutamide. But we did do, as I went into a bit of detail in the presentation, what's called an ER analysis, an exposure response analysis. And through this analysis, we looked at a broad range of variables that captured exposure a bunch of different ways, efficacy a bunch of different ways, and same for safety. And the bottom line for the efficacy analysis is that there was no statistical relationship between exposure and efficacy. It's not really surprising because both of the doses that we took into dose optimization were above the minimum concentrations that we were projecting from our preclinical work, and the pharmacodynamic signal that we were looking at maxed out even at 200 milligrams. So the 4 and 6 were, in our minds, highly likely to be clinically active. So, but, anecdotally, if you look at any individual readout for the various efficacy measures that we looked at, in some of them, the 400 was numerically higher than the 600. In others, the 600 value was higher, but the confidence intervals overlapped. And so you can't draw a conclusion from any single comparison as to which dose would be better. It's the ER analysis that really makes that assessment. But that wasn't the case with respect to safety. We saw a clear relationship between exposure and multiple measures of safety, adverse events of interest, treatment modifications, and it shows up when you look at the side-by-side safety tables for 400 and 600. 600 has more toxicity, mostly grade 2 over grade 1, and it also has more dose modifications. So the bottom line was that there was no advantage in efficacy, but there was an additional toxicity burden with the 600, which is why we concluded the 400 would be the RP3D. And frankly, that's kind of what FDA wants companies to do when we do these Project Optimist type of exercises, is to move away from just assuming that higher is always better. I think we have conclusive evidence to support the 400 milligram dose as the RP3D, and we want to sort of look forward and plan for our first phase 3 study and potentially others as well after that.
Got it. That's really helpful. And you're showing low rates of progression and low discontinuation rates. What are some of the other reasons for stopping drug as observed in your swimmer plot data, or how should we contextualize that?
Sure. So, the events in a radiographic progression-free analysis that you capture as events are radiographic progression on imaging or death from any cause. So if patients are alive and progression-free, they're censored at their last visit or the last time they had imaging done. But patients can also be censored if they're lost to follow-up or come off of treatment for other reasons other than progression. And these can be a variety of reasons, like the patient withdraws consent because they don't like the study visits, PSA progression where they may want to go on to another therapy even before they've progressed radiographically, or tolerability issues. They don't like the side effects. In our plot, we do have some patients like this, and it's typical in prostate cancer trials. Actually, if you look at the Mevro swimmer plot from ASCO GU, many of those patients are off treatment, but without a progression event defined. 6 of their 14 are off for this reason. So it's not unexpected in this patient population in these kinds of studies.
Got it. That's helpful. Thank you for taking my questions.
Thank you, Maury.
Thank you. And one moment for our next question. Our next question will come from the line of Kelsey Goodwin with Piper Sandler. Your line is open. Please go ahead.
Oh, hey, thanks for taking my questions and congrats on the update. Maybe first question, for this combo data, maybe just remind us that this was the fasted, I believe. And then in terms of this food effect cohort that you're running now, maybe just tell us what the purpose of that is. Did the FDA require it, or are you doing that on your own? And then is that in response to Pfizer also running a food effect study, dosing at or looking at the higher dose fasted and then a lower dose while fed? Maybe just some more color there would be helpful for us. Thank you.
Thanks, Kelsey. Yeah, Pratik can take that one.
Sure. So it's a good question. So before I answer that, let me provide some context, and you were actually covering some of those points already. There's a couple reasons to do food effect studies, as you said. So first, it's an FDA requirement. They want to know whether dosing with or without food affects the exposure of your drug, and if there's any meaningful effects of those changes in exposure on the safety and efficacy profile. Ideally, you wouldn't want to have a food effect. That would give you much more flexibility and a more convenient dosing regimen. The patient can take it however they want. But if there is a true food effect, then you may have to revisit dose and be stricter in terms of patient instructions on how to take the drug. But as you said, the other reason to look at the food effect is that it may improve the safety profile of the drug. Mostly GI toxicities like nausea or vomiting and diarrhea. And you might want to do this even if there's no meaningful food effect on drug exposure. So if we start with our drug, Rinzimetostat, so we're mostly conducting our food effect to satisfy the FDA requirement. And as I said during the presentation, so far we don't see a meaningful food effect. We looked at this initially as a single agent, and now we're doing this again in the combination with the Rinzi-Dara combination. And Part of the reason is that since darolutamide is taken with food, we want to see if we can make sure that the Rinzi can just be taken at the same time, which will be more convenient for patients. So far we aren't seeing much in the way of a true food effect. In terms of just the effect on safety, so far in the first patients that we've treated on this little cohort, we've only seen grade 1 treatment-related adverse events, except for one grade 2 event of decreased appetite. Maybe there's some potential for incremental improvement in GI tox beyond the clean profile we have, but it may stay very much the same. And then in terms of efficacy, you saw from the initial PSA data, it looks very consistent with our FASTA data. The early activity that we're seeing out of the 5 patients, we have 2 PSA 50s and 1 PSA 90. All of them are confirmed. So that's our story. With mevrometostat, the story is a bit different because it does seem to have a meaningful food effect. Since their FASTA dose of 1250 is, if you do the math, 44% higher than the fed dose of 875, but you get to the same exposure in each of those instances because of the food. So there is a meaningful food effect, but I think they really chose the dosing with food to improve the GI tox. They had a nearly 80% rate of diarrhea with their fasted regimen, and it dropped to just below 50 with dosing with food. But as you might notice, it doesn't affect the other adverse events like heme tox, which comparing the 1250 to the 875 is about the same, if not maybe a little higher with the fed regimen. So our reasons and Pfizer's reasons for doing the food effect are actually pretty different.
Okay, got it. And then maybe one follow-up. In terms of the second half program update that you guided to earlier this year, now that we have this first quarter data set out, I guess, are you providing any more color on what that might look like?
I can take that one, Kelsey. No, not at the moment. I'd say, we do have that second half program update, but right now it's TBD in terms of what additional data, if any, we would plan to disclose during that update. We'll refine that thinking in the coming weeks and months and let you know.
Got it. Thanks so much.
Thank you.
Thank you. And one moment for our next question. Our next question comes from the line of Colleen Kusy with Baird. Your line is open. Please go ahead.
Great. Good afternoon. Thanks for taking our questions and congrats on all the updates. A couple on safety for us. Can you just comment on any rates of cytopenias or alopecia that you're seeing? I believe that's something that we saw in Pfizer's program. And then on the blood creatinine increases that you saw with both doses, can you just provide a little more color there? Do you think that's a drug effect, a Rinzi class effect? Any color there? Thank you.
Thanks, Colleen. Pratik can take both of those.
Sure. So your first question was on the cytopenias or alopecia that Pfizer sees. So in terms of cytopenias, we do see both neutropenia and thrombocytopenia, but at a low rate, less than 5%. PRC2 inhibition as a class does lead to hematologic toxicity, and it was the dose-limiting toxicity in our single-agent dose escalation experience, but that only occurred when we pushed the dose up really high. We have a wide therapeutic index with a great sort of long half-life, so we don't have to deal with a high Cmax, and we're able to work within dose ranges that limit the cytopenia complication. And then in terms of alopecia, we've seen a grand total of 1 treatment-related alopecia event of grade 1 at the 600 milligram dose, so we see maybe a smidgen of it. And then in terms of the blood creatinine increase, so our rate from the table we presented at the 400 is 16%, mostly grade 1. The increase in blood creatinine in older patients most often is an indicator of dehydration. And if you look at the other adverse events that these patients are experiencing around the same time, you see these events track with some sort of concomitant or preceding GI adverse event like nausea or diarrhea, which leads to decreased oral intake, and then they get dehydrated, and then the creatinine goes up. Good news is that it resolves easily with hydration, and the creatinine rise reverses. In terms of whether this is seen with mevrometostat, it's hard to say because in terms of the mevrometostat profile, we only have insight into the adverse events that they've disclosed in over 20% of patients. So we don't know what the adverse event profile looks in the short of 20% of patients. So they very well could be seeing it, but it just hasn't been disclosed.
Got it. Helpful. Thanks for taking our questions.
Thanks, Colleen.
Thank you. And one moment for our next question. Our next question comes from the line of Derek Archila with Wells Fargo. Your line is open. Please go ahead.
Hi, this is Simone on for Derek. Congrats on the data. Just two from us. One, will you have a drug supply agreement in place before initiating the phase 3? And two, can you walk us through expectations for timing of the phase 3 top-line data readout and what assumptions go into that? Thank you.
Thanks, Simone. I'll take your first question on the drug supply agreement, and then Pratik can cover your second one. So I think probably all I can say at this point, we continue to have excellent working relationships with our partners at both Bayer and J&J. Obviously, we can't comment on the specifics of any ongoing confidential discussions, so it's probably best if I just leave it at that for now, and we'll provide a public update at the appropriate time.
And then I can answer the second one. So we, as we said in the call, we expect to start the first phase 3, Himalayas-1, in the first half of this year. So depending on the exact timing of the study start, we'd expect top-line data in late 27 or early 28. So that assumes a 16-month time to fully enroll the study, which would be actually a couple months longer, a bit of a buffer than what we believe Pfizer took to enroll their MEVPRO-1 study in the same patient population. And then you'd need to add some additional time for us to get to the necessary number of PFS events for the final analysis. So that's kind of the general time frame.
Thank you. And one moment for our next question. Our next question will come from the line of Corinne Johnson with Goldman Sachs. Your line is open. Please go ahead.
Hi, this is Eric on for Corinne Johnson. Thank you for taking the question. I have two questions. And first is there a corresponding Kaplan-Meier curve that you use to generate the landmark PFS analysis? And if so, any color would be helpful. And second, we're hearing anecdotes that abiraterone usage may be slowly decreasing. How do you reconcile that with the approximately 50% stable market share data you presented in one of the previous slides? Thank you.
Yeah, great. Thanks, Eric. I'll ask Pratik to take your first question on the Kaplan-Meier curve, and then our head of commercial and medical affairs, Keith Louie, can take your second question on the rumored attrition of abiraterone.
Yeah, sure. So on the Kaplan-Meier curve, so we have a median follow-up of just about 5 months, and so a Kaplan-Meier curve would be immature past that point. So that's why we focused on landmark analyses through the time point where we have our median follow-up. So, with a median follow-up of 4.9 months, that's why our landmark goes out to 5 months. But we have multiple patients approaching or beyond this median that are still ongoing. So the curve is going to be unstable past that point. And so you're not going to get a good read on the later time points. But you can, with the swimmer plot and a bit of graph paper, draw out what the Kaplan-Meier curve is going to look like. I would just say that it's going to be unstable and therefore far less helpful beyond the median follow-up time points.
Yeah, and then maybe to comment on the second question, this is Keith. Given that the abiraterone population is going to be the focus, the post-abiraterone population is going to be the focus of the Himalayas-1, we pressure tested our assumptions about market size from multiple different angles, both quantitatively and qualitatively. And so to develop our market assumptions, we've gathered numerous data points from real-world clinical trial and third-party prescription data. You saw some of the representative examples of those data in today's presentation. We then triangulate those data with our own market research efforts and then even further validate our insights by speaking with dozens of healthcare professionals. And these are professionals not only in academic settings, but importantly in community settings where about 80% of prostate cancer patients are treated in the real world. We also spoke with a wide swath of both oncologists and urologists, and we continue to hear from those conversations that there is a strong preference for abiraterone, and its usage continues to be highly sticky, which is why it's still by far the most prescribed ARPI and has maintained relatively stable share of new ARPI prescriptions at around 50% that I presented over the last 5 years. And the reasons cited are given that it has widespread and long-standing physician experience with the drug, payer preference given that AbbVie is generic, and evidence-based medicine reports that starting AbbVie first in the sequencing of ARPIs results in longer durability than if AbbVie is sequenced later. And so based on all of this, we feel really good about the market prospects for that patient population we're studying in Himalayas-1.
All right, appreciate it. Thanks.
Thank you. And one moment for our next question. Our next question comes from the line of Yigal Nochomovitz with Citigroup. Your line is open. Please go ahead.
Thanks. Thanks for the questions. Congrats on all the updates. Just a few things. So you mentioned, of course, there's the potential for another phase 3 trial. And I think, Jacob, you said what you've shown today doesn't preclude using APA next. But I guess the question is the preference still for DARA for the second phase 3, say in the post-AR setting, especially since you showed some of that post-ARPI data already today? So that's the first one. And then second, just with regard to the safety, of course, I appreciate the comments and the survey data you showed with the preference for 80% of the time for Rinzi. My question was just with regard to exposure times and whether you had to do any normalization or adjustments for median follow-up, given it's obviously about half the amount for Rinzi versus what you have for Mevro. And then the last question is anything you can say with respect to other feedback from the prostate cancer KOL community. You noted some of the luminaries on the slide at the beginning of the presentation. Anything else that people are commenting on with regard to what you're showing today? Thank you.
Thanks for the questions, Yigal. Yeah, I'll take your first one, and then I'll ask Pratik maybe to comment around your questions on safety and the investigator feedback. We're generating great data. We've continued to generate great data with both of the combo partners, Yigal, both of the AR inhibitors, so darolutamide and apalutamide. I would say even though the data that we flashed up today was all focused on the darolutamide combination, including in that sort of experimental population where we're signal seeking, frankly, for the post-AR inhibitor population, which might be a future phase 3 study, all of that focused on darolutamide today. But we don't have a preference for what we might do for that second or third phase 3 study as well. Obviously, for simplicity's sake, we chose to focus on darolutamide for this first phase 3 study, but we're kind of keeping the door open on what we would use for future phase 3 studies. Maybe let me have Pratik take the other questions.
Yeah, so in terms of the Kaplan-Meier comparisons, you're absolutely right. We have a different amount of follow-up. We have less follow-up than Pfizer does for their patients, which is why we stuck to the landmark analysis. So, the 3, 4, 5 months with our median follow-up of just about 5 months, those, comparisons we think are fully valid because, at that point that curve is quite stable. It's when you get, past the median follow-up that comparisons, I think, then become sort of tricky and not, not really tenable. So that's, I think we stuck to that just to be strict in terms of where the curves are comparable versus where they're not yet. More follow-up,
okay.
We will push out that analysis. In terms of the,
I guess I was referring to more on the safety side, though. That would apply as well on the safety side of things in terms of looking at the rates of different AEs.
Sure. Yeah, but the safety develops. We don't have new safety events that sort of develop for 5-6 month time frame. If they're going to develop toxicity, it happens in the first, if not the first, the second cycle. So I don't feel like the safety profile is going to, worsen over time.
Yeah, Yigal, the safety kind of is what it is. And one of the reasons why we, pulled back the curtain even a little bit more here on the safety side to show the full experience, not just the post-AbbVie, but even the post-AR inhibitor patients, was to really bolster the N that you all were looking at to give everyone confidence that the profile that we're showing you for safety in that post-AbbVie population is in fact the safety profile for the drug, because you obviously see the trends don't change when you look at the full post-ARPI population. And then Pratik can just comment quickly on the investigator feedback.
Yeah. So, I mean, I think the long and short of it is, our investigators are very excited to be part of this new study. You already cited, I think the most visible proof is that we've got a top flight steering committee with thought leaders from around the world. World's top institutions are represented. But, to be more specific, I think, everybody's looking for an all-oral therapeutic option for these patients with MCRPC. There's a lot of, even though it may not always be on the guidelines, there's so much ARPI switch because physicians and patients want to maximize their time on an oral regimen. And so, this whole class PRC2 inhibition potential to have an all-oral regimen that may be, better, at least have a potential for a long PFS, I think is very exciting. And then, just to distinguish between the two programs, I think the safety profile that we're seeing with our program has our current investigators very excited, and they've signed on from the phase 1 onto the phase 3 for that very reason, because they think that this drug is highly competitive to what's out there.
Thank you.
Thank you, y'all.
Thank you. One moment for our next question. Our next question comes from the line of Corey Kasimov with Evercore ISI. Your line is open. Please go ahead.
Hey, good afternoon, guys. Thanks for fitting me in. So curious if there's anything to read into the rPFS flattening from months 4 to 5. Is it just too small of an end to kind of extrapolate there? And then a follow-up is, I'm curious, is there any reason that there are different cutoffs for the efficacy analysis, at least in the swimmer plots, which I think it's like March 9th, and then the safety data, which has a cutoff in January? Thank you.
Thanks, Corey. I'll have Pratik take both of those.
Yeah. So, I mean, I think you already answered the first question, which is, there's a few patient numbers. So it remains flat. The curve remains flat over that interval. And in terms of the cutoff, so what the cutoff is really January 16th, but then we extended the follow-up of those patients to the March date so that we could have more PFS to look at.
Okay, got it. Thank you.
Basically, Corey, just trying to eke out as long of a landmark PFS as we could, just to give everyone confidence in how it's tracking.
All right, makes sense. Appreciate it.
Yep. Thank you.
Thank you. And one moment for our next question. Our next question comes from the line of Matthew Biegler with OpCo. Your line is open. Please go ahead.
Hey guys, thanks for fitting me in as well. I just wanted to ask about dysgeusia because it doesn't seem like you're seeing much, if any, of it, and it's been flagged by a lot of KOLs we talked to as a big tolerability issue with mevrometostat. So, any idea kind of why the low rates? Because I always thought it was more of an on-target tox, but maybe it's just reflective of the lower doses that you're using here. Thanks.
Thank you, Matt. Yeah, Pratik will take that.
Yeah, sure. So we do see it at a low rate, again, probably like less than 5%. I think actually, I wouldn't say that we're using a lower dose. And I just want to be careful about that. So Pfizer in some of their presentations have correlated safety with a Cmax. And the Cmax is, for their drug, because it has a short half-life, they still have to give very high doses in order to get coverage above a Cmin, a minimum concentration over 24 hours. So it's dosed BID with still, even with food, 875 milligrams twice a day. So they're going to get big swings from peak to trough, and that is potentially going to drive the toxicity. We have a lower dose. I mean, it's a different molecule, but since we have a full 20-hour half-life, we have a much lower swing between peak to trough, and so our Cmax, relatively speaking, doesn't go as high. And so, we're able to essentially cover the target without necessarily incurring the safety liability from the Cmax. And so, I think that explains a lot of the issues that we don't see with heme tox in particular. We see less GI tox, and so I think that would be the explanation I have for those differences.
Appreciate it.
Thank you, Matt.
Thank you. One moment for our next question. And our last question will come from the line of David Nierengarten with Wedbush Securities. Your line is open. Please go ahead.
Hey, thanks for taking the question. I just had one on, when you look at your side effect profile and discontinuations, the actual discontinuations appear pretty comparable to Mevro, across trials. I mean, is that, what we should be looking at, or should we be really looking at the actual grade 3 adverse events? And if so, several of them from Mevro just seem to be lab values versus, diarrhea or nausea. And maybe you could just walk us through, like, what are you looking at and prioritizing, or what the doctors are in your survey work? Thanks.
Thanks, David. Yeah, Pratik will cover that, including, we get a lot of just qualitative guidance from doctors, obviously, who are familiar with both drugs and who, give us some color in terms of what are the more problematic AEs for Mevro. So Pratik can kind of highlight all of that.
Yes, I mean, I think, there's a range of treatment modifications, and you're right that the discontinuation rate is not, terribly distinct. But I think where you also have to focus is treatment interruptions and dose reductions. Dose reductions, because of toxicity, often, almost inevitably lead to some treatment interruptions. You may be able to keep the patient on drug, but you're now lowering the dose, and, I'm not sure if you have to lower from the Mevro 875, how much coverage you're going to get. And so that patient's going to be either underdosed or uncovered if you're going to do a dose interruption for a period of time, yet they're not going to technically have a treatment discontinuation. And so that's where I think the safety profile distinction in terms of adverse events, the grade 3s, maybe they can get patients through a grade 3 toxicity, but they got to hold the dose or lower the dose, and, and they haven't discontinued, but they're on a lower drug and have had meaningful treatment gaps. Whereas, we have the potential with this safety profile to have a continuous dosing for a given patient because they don't incur toxicity that requires those kinds of modifications.
Okay, thanks.
Thank you. This does conclude today's question and answer session. Ladies and gentlemen, this does conclude today's conference call. Thank you for participating, and you may now disconnect. Everyone, have a great day.